Dowels and Durability, my science project, and I'm Jacob Horizon, your host, and we will be testing how much strength a piece of basswood has when in different temperatures. Now, the overall experiment, this will be set up. We'll just have a piece of wood, dowel, 3/8 by 3/8, and then it's a yard long, suspend it between two posts, basket in the middle holding weights, and then we'll just increase the weight until it snaps. Try it inside where it's warm, try it outside where it's cold, see which one snaps faster. Now the hypothesis is that outside it will be much colder and therefore make it more brittle, just because things are generally become more brittle and less flexible in the cold, so I think it'll snap under less weight outside. Now, some materials we'll be using 2 clamps to hold down the wood at each side, 2 sticks of basswood, of course, and then 2 posts to hold the wood and the cradle above the ground. Now you probably don't want them too high or else everything on the cradle will fall and hit the floor very hard. Then also you want some set of weights, at least going up to about 20 pounds in weight, some string or tape to attach the basket to the piece of wood, then also the actual plate or basket or frisbee itself. Alright, and then some variables to consider. We have the independent variable, which will be the temperature the test is done at. We have the dependent variable, will be the weight at which it snaps. And then the control group will be the actual experiment itself. So now, alright, let's get started. Okay, again, this little wood is thwarted many of the tries I've got. I believe it is now wood 5, science 0. But, time to throw out the big guns, 15 pounds. We already know it withstands 15 pounds because we did that in the last test. Again, 70 degrees, 2 clamps on the sides, basket right in the middle. Let's try this. 2 pounds. Remember, safety goggles are key. This could snap into my face at any moment. Let's take another 2 pounds, why not? Making it 19 pounds. That is what I call a result! We have done it! There you have it, 19 pounds. And the stick goes kaplooey. Now, done with the first part, there it goes. Now we have to replicate it outside in the cold. Alright, so we made it through the first test. Now on to the second one. It's a real doozy. Right now I'm outside in the wilderness. Not really, backyard. But anyway, it is 35 degrees outside, which is not very comfortable. Also, we have the exact same rig as before. Everything's set up, same type of wood, same type of tray, same clamps, so we're rocking to go. Just to make sure we don't skip and jump too far in the weights. We're gonna start small as we did in the first one and gradually grow up, but you know, in somewhat more appropriate increments. First off, 2 pounds. Now this is where it snapped before, so let's go for gold. There we go. That is a result. Let's replace this with a 3-pounder, increasing it by 1 pound for those of you poor math people. I'm lifting as I adjust this stuff, so I'm not adding too much pressure at one moment. Actually, I have some bowing in the tower. Oh. There we have it, our result. What is that? 15, 5, that's 20 pounds. We have a winner. Well, there we go. We have our data now. Indoors, 71 degrees, snapped at 19 pounds, 6 ounces. Outdoors, 35 degrees, snapped at 20 pounds, 6 ounces. And there's our results. It is actually increasing in tensile strength outdoors rather than indoors. So the colder the temperature, the stronger the strength, in theory. Now, for analyzation, there could be some few slight problems with margin of error. I mean, the weights, we increased the weights by 2 pounds each time, So increasing the weights by smaller increments would give us a more accurate reading. Another problem could be, I noticed in the outdoor one, and the clamps that were holding the wood down at the end so it would bow upward, those clamps were starting to raise up slightly. And now that could have caused a bit more flexibility in the stick, which could have caused it to break at a slightly higher or lower, would have caused the stick to break slightly later after more weight was applied. So that could have been a problem. Another thing was that the stick was not frozen, it was merely chilled, which means that there was no extreme physical change taking place, so if it were frozen, we would have a slightly more absolute telling data. But there you have it. The question is now answered. That basswood does in fact increase in tensile strength when in lower temperatures. So now, supposing you are wondering that at some time in your life, you now know. So thank you for watching, and thank you for watching.